Chalo bachcho, welcome. Today we're going to learn a very important topic from Unit 6, the experiments of Faraday and Henry. Don't worry, we will make it so simple that you will never forget it and every point will be perfect for your exams. So let's start with a puzzle that even stumped scientists for a long time. Is it possible to generate a current in a wire without a battery and, get this, without moving anything at all? Sounds impossible, right?
Well, the answer to that puzzle is surprisingly simple. And you know what? It's the one single idea you need to remember for this entire chapter.
The secret is just one word: change. It's not the magnetic field itself, but the change in the magnetic field that creates the magic. A steady, strong magnetic field, it does nothing, but a changing one, that does everything.
Think of it like this, okay? The charges in a wire are kind of like cars waiting at a traffic signal. As long as the signal is steady, red or green, nothing new really happens. But the moment that signal changes from red to green, what happens? The traffic starts to move. In the same way, a changing magnetic field is the signal that tells the charges in a wire to start moving. Now, let's see how Michael Faraday and Joseph Henry actually proved this idea. We're going to look at their 3 classic experiments that became the foundation for, well, everything. First, the official NCERT definition for your exams. Listen carefully. Electromagnetic induction is the phenomenon where current is generated by a varying magnetic field. Remember that word varying. Now, let's see the proof. They used 3 very clever setups to show this. First, they moved a magnet near a coil. Then, they moved a current-carrying coil near another coil. And finally, and this is the most brilliant part, they produced a current without moving anything at all. So, in the first experiment, as you can see, when a bar magnet is pushed towards a coil, the galvanometer needle deflects, which shows a current. Simple. When it's pulled away, the current reverses. But what happens if the magnet is just held still? Absolutely nothing. Zero current. For the second experiment, they just replaced the permanent magnet with another coil carrying a steady current. Basically, an electromagnet. And guess what? Moving this electromagnet towards or away from the first coil also induced a current. This proved that it's the relative motion that matters. And this third experiment, this one is the real breakthrough. Here, both coils are held perfectly still. They just press the switch to start the current in one coil. Now, the moment they did that, the magnetic field grew from 0 to its maximum. And this change induced a momentary current in the other coil. No motion needed at all. So the crucial takeaway from all 3 experiments is this. An electromotive force, or EMF, which you can just think of as the push that drives the current, is induced only when the magnetic flux, that is, the amount of magnetic field passing through the coil, changes with time. And it's not just about the change, it's about the rate of change. A faster change means a bigger push and more current. Okay, bachcho, tension nahi lena, but pay very close attention now. I'm going to tell you about 2 silent killer mistakes that students often make in exams that can cost you marks. The first mistake is thinking that a very strong magnet just sitting next to a wire will create a current. No, it doesn't matter how strong the magnet is. If the magnetic flux isn't changing, the induced current is 0, absolutely 0. And the second mistake, believing that only physical movement works. As experiment 3 showed so beautifully, you don't need to move anything. Just changing a current in another coil is enough to change the flux and induce a current. So just remember this simple line for your exams: no change in flux, no current in the circuit. Ye point note kar lo. This is the most important summary of this entire concept. All right, let's just quickly summarize what we've learned from these amazing experiments. Let's make sure all the key points are crystal clear. So here are the 4 key takeaways. Number 1, an electric current is induced only when the magnetic flux through a coil changes. 2, the real cause is the rate of that change, not just the flux itself. 3, this change can happen because of relative motion. And 4, it can also happen by simply varying the current in a nearby coil with 0 motion involved. Now, understanding these experiments is so critical. Why? Because they're not just some old lab tricks. They form the physical basis for the next big topic we're going to study: Faraday's law of induction, which puts a precise mathematical formula to these very ideas. And just to leave you with a thought, consider this. This simple principle, discovered with just a coil of wire and a magnet, is exactly how the giant power plants generate the electricity that lights up our entire world. From a tiny flicker in a small instrument to powering entire cities, all because of one single powerful word: change.